Assalamualaikum and good evening. So today I'm going to present my final year project proposal presentation. My name is Nur Shakira binti Romli, metric number 188774. So basically my title for final year project is In situ epoxidation of waste cooking oil using peracids. So my supervisor is Dr. Muhammad Faiz Mohtar bin Gunam Resul. Okay, so this is my presentation overview for today, sort of like a structure. So I'm gonna start with introduction, a little bit of information about waste cooking oil, epoxides, and epoxidation itself. And I'm gonna continue with my research objectives, and also continue by my experimental procedures. And finally, I'm gonna end my presentation with expected results from my study. So, why waste cooking oil? So I choose waste cooking oil as my raw material for a few reasons. So first of all, let's take a look at the definition of waste cooking oil itself, which is waste cooking oil is a cooking oil that has been used basically for at least 1 to 2 times or more. So the issue arises is when improper waste management is being done by the community that leads to water pollution, land pollution, as well as sewage problem. So according to some research that has been done, in one community, there's about 67% of people in that community that discarded their waste cooking oil into drainage and also soil. So this could actually lead to a lot of problems, even to water, land, and especially our sewage lah. So it is we know that there are some of process that utilize waste cooking oil, such as converting waste cooking oil into biodiesel and so on. But now, as we can see, people are still not having the conscience and not having the common sense to utilize their waste cooking oil. So we are proposing another initiative or another method to utilize waste cooking oil, which is to convert waste cooking oil to epoxides, where these epoxides has the potential to be further converted to bio-based polymer, and this bio-based polymer can be substituted to petrochemicals, which we know crude oil are begin to extinct day by day, so we have bio-based polymer as a substitute. So why epoxides? Okay, basically epoxides is an intermediate group that can be converted to any chemical compound according to required or favorable functionality that we want. So it does not only can be converted into bio-based polymer, but it can also be converted into bio-based polyester and so on, according to what we add into it. So epoxide is very good molecule because it does not restrict you into one product only. Okay, so we go through on epoxidation. Epoxidation is the reactions that convert fatty acids into epoxides using peracids, helped by what is that? Hydrogen peroxide and also acetic acid. So waste cooking oil, some of study have said that waste cooking oil can be fully epoxidized to epoxides in more than 90% yield. That is for the normal epoxidation. But if we use in situ techniques, we'll get for about 78% of yield of epoxides. Okay, so continue with my research objectives. The first thing is I want to utilize waste cooking oil as my raw material to produce epoxide, or also called as oxirane. Second is to produce epoxides from waste cooking oil using in situ parasite epoxidation. So this is my method lah. And then the last one is to investigate process parameter, including the effect of temperature, mixing speed, and oxygen ratio. Actually, sorry, there's a bit of mistake. Mixing speed, temperature, and also hydrogen peroxide concentration. So we manipulate this thing to get our epoxides. Okay. So continue with my experimental procedure. So basically, we will start with filtration of waste cooking oil. This is a basic method where we filter waste cooking oil so that we can remove excess solids or undesirable substance that we don't want, that can affect the experiment. And then we go through esterification of waste cooking oil so that we can get the fatty acid that we want. This is where we analyze fatty acid. We want to see whether our fatty acid really contain double bond or not, so that the double bond can be if there is double bond, then can we do the epoxidation. So after that, we do in situ epoxidation for the fatty acid. Here we manipulate three things which I had said before, which is the temperature, mixing rate, and concentration of hydrogen peroxide. Okay, so we manipulate the temperature from some range 40 to 80, mixing rate from 1200 to 1800, and concentration of hydrogen peroxide from 1 to 2.5 ratio of hydrogen peroxide and waste cooking oil. And last one is we analysis of oxygens lah. So we want to see whether we get the highest yield of oxygens in which operating condition. So we want to get the highest oxygen, so we're gonna use different range of operating condition. Okay, so from here we also for my last experiment, I'm gonna use gas chromatography to analyze the oxygen in the substance. So we want to see if there is a peak that shows that it was the oxygens that exist in our sample by using GC method of analysis. Okay, so lastly, for my expected results, so according to research, we want to have oxygen by using doing the experiment at optimum temperature, at which 50 to 60 degrees C. So we believe that at 50 to 60 degrees C we'll have the maximum yield of oxygen, and 1800 to 1900 revolution per minute is for the mixing rate, while 1.5 to 2 mole ratio percent of waste cooking oil to hydrogen peroxide is for the ratio. So we hope that this result will be I hope that I will get this kind of results, because I want to get the highest yield of oxygen. So that's all from me. Thank you for watching.